All right, today we're going to look at rational numbers, which is chapter 3, lesson 2. Okay, now we have used this word before. Does anyone know what a rational number is?
No way.
There are a couple people in this room that should know.
No, I do not.
A rational number is any number that can be written as a what?
Fraction.
Fraction. Good. Okay,
Yes.
so what do you think if we're doing rational numbers, and the rational number is any number that can be written as a fraction?
We're turning them into fractions.
Yeah, we're turning things into fractions today. Okay. All right, so that's what we're going to be doing most of. The first thing I want to do is I want to give you this chart, okay, that we're going to use to identify numbers. So if you want to write this on your paper, that would be a good idea, okay? Now, you don't have to make yours take up the whole piece of paper, okay? Yes, I just drew a rectangle and then drew 3 rectangles inside of it, okay? So that we can label these things. You're going to see why in a minute after we get through talking about this, all right? So the first thing we're going to talk about is natural numbers. Natural numbers are just numbers 1, 2, 3, all the way to infinity, okay? So they're similar to whole numbers. They're actually exactly the same as whole numbers, except whole numbers also include what other number?
A 0.
Say it again, Dylan.
A 0.
0. Okay, so are whole numbers and natural numbers exactly the same with the exception of 0?
Yes, sir.
Yes, they are exactly the same. Remember those 3 dots at the end means that keeps going. This does not mean it's only the numbers 1, 2, and 3. Is 15 a whole number?
Yes.
Yes. Is 1,000?
Yes.
Yes, 1,000 is both whole and natural, okay? So that falls under both categories, okay? All right, the next one we're going to talk about, we've already done and taken a vocab test over. What is an integer?
A negative number. Opposite.
Say it again.
Number.
Negative or
And it's opposite.
positive, yes. So, negative and positive whole numbers. Can you have a decimal that's an integer? No. So, notice on this one, the dots extend to the negative side and the positive side, right? Because again, is negative 48 an integer?
Yeah.
Yes, because it's a negative whole number. Is positive 52? Yes, because it's a positive whole number. Okay? All right, we're going to put rational numbers next. Remember we said can be written as a fraction. Does that mean it definitely starts as a fraction?
Yeah, no.
No. It means it can be written as a fraction, okay? So, can anyone give me an obvious example of a rational number using the definition?
Wait, what?
If a rational number is any number that can be written as a fraction, what would be an example of a rational number that's already a what?
A fraction.
Okay,
2 over 4.
okay, which would be 1/2, right?
Yeah.
Isn't 1/2 obviously a rational number because it's already a fraction?
Yeah.
Anytime a number is already a fraction, you know it's going to be rational. Okay. Now we're not just going to keep naming fractions. We want to come up with some other examples of numbers that we could change into a fraction. Okay. Can anybody else give me an example of something that's not a fraction yet, but we could change to a fraction? Dylan? 5. Okay. How could you change 5 to a fraction?
5 over 10.
Not over 10.
1 over 5.
5 over 1.
5 over 1. There we go. Whole numbers or integers always get put over 1. Okay? Right? Because isn't 5 divided by 1 still 5?
Yeah.
Yes. Okay? Can anyone else give me another example of some other type of number we could make into a fraction?
Negative 1. Negative 4. Yeah, negative 4.
Okay, but so, yes, but negative 4 is the same type of number as 5. It's an integer. Okay? So, you'd still just put it over 1. I'm thinking of a different, some other type of number.
0.
Decimal. Good. What? Give me a decimal, Ethan. Just a simple one.
1/6.
5.3.
Okay. Well, I heard 0.6 first, so I already read that.
Thank you.
Okay. All right. So that would be equal to 6 over 10, which would simplify to 3/5. We're going to talk about how to change decimals to fractions in just a bit. Okay. What about 1 2/3? Can I change that? What type of number is that?
Mixed.
Mixed number. Can I change a mixed number to a fraction?
Yeah.
Yeah, right? That's going to be 5 over 3. Again, we'll talk about that in just a second. So there's a lot of different ways rational numbers can look before they're a fraction, right? Including this. Do what?
I was 5 over 3.
We're going to talk about that in just a second. Okay?
What is that? How do you write that?
The square root of 81.
Is that like- yeah.
Now, can anyone tell me why the square root of 81 could be a rational number? Does anyone know what the square root of 81 is? Who said that? Good. 9, right? Now, if the square root of 81 is 9, how would you write that as a fraction, Dylan? We just talked about it a second ago. You'd put it over,
9 over 81.
no.
9 over 9.
Whole numbers always get written over what?
1.
1. Okay? Because when you take the square root, you get 9. To write as a fraction, you get 9 over 1. Okay? So, yes, it can happen. Same thing if you have the negative square root of 36, right? What is the square root of just 36?
1.
No,
6.
6. So if there's a negative in front, then it would be negative 6. And then as a fraction, we always put it over 1. Okay? Yes. Now that only works because the negative is out front. It's not underneath the square root. Okay? Then it's no solution. Because you can't take the square root of a negative number. Okay? Kylie?
How do you figure out what the answer to a square?
Okay, good question. What, can anyone tell us, how would you figure out the answer to a square root?
Absolutely not.
It's not divided by 2.
Divided by the number that multiplies it.
Yeah, so that, yeah, yes. An easier way to say that is what number times itself reason is 36.
Like 9 times
Right?
9 is 81.
What number times itself is 81? Because taking the square root is the opposite of squaring a number, okay? So, what number times itself is 36? 6 times 6, right? What number times itself is 81? 9 times 9. Does that make sense, Kylie? Okay. Ethan, were you going to ask a question?
No.
Okay. All right. Last thing on this is irrational number. So if a rational number is any number that can be written as a fraction, irrational numbers would be what? Oh, come on. If a rational number can be written as a fraction, irrational numbers can't be written as a fraction, okay? So typically an irrational number is a decimal that does not terminate. That means it keeps going forever. What's the most famous example of a decimal that does not ever end?
Repeating. Hi.
Pi.
33.
Hi. Did you guys just say hi?
Pi.
Okay, Kaylee. Okay, so pi, we know 3.14159 ... keeps going because that decimal does not end, okay? So if you have a decimal that does not end, that's going to be irrational, okay? So let's talk about how we're going to use this to identify our numbers. Anybody still writing any of that down?
No.
Okay, here we go. So all we're doing here is just trying to identify the set of numbers that this belongs to, okay? Now, anytime that you see a negative, can it be a whole number or a natural number?
Do we
Yes.
divide it?
No, just wait. We're trying to identify the set. So what we want to say is,
Set.
look, these names right here. Rational,
Oh, it's rational.
integer, hold on, stay with me. Rational, integer, whole, natural. Okay? If you put irrational, will you ever put any of these?
No.
No. Okay? So here's the first thing. What was the number I just gave you?
-2, 6 over.
-2 and 6/11. Can that be a natural number?
No.
No, because it's not positive. Can it be a whole number?
No.
No, because again, it's not positive. Could it be an integer?
No.
No, why?
Because there's a fraction.
Because it's the fraction. So what's the only thing it could be? Rational number. Okay? So on this, we would say just a rational number.
I thought it was like rational.
Rational.
When I first saw it.
Okay? All right, let's look at 1.31, 331, 3331, ...
Irrational.
Okay, why is this irrational?
Because it keeps going.
Because it keeps going, okay?
Don't tell me I'm wrong.
Okay, anybody want to try this one?
Oh, I know.
you're going to name all sets to which it belongs. Remember, it could be more than one. Okay? All right. Kaylee, what do you think?
Natural, whole, and integer.
Just those three?
Yeah.
There's one more.
Rational.
What's that? Not rational.
Rational.
Did I get a second head?
Okay, here's the deal. If a number is a natural number, it has to be everything else. Okay? Right? It has to be also a whole, also an integer, also a rational. Okay? Ethan?
What's the difference between a natural number and a whole number?
One number, one single number. What is it?
Zero.
Zero. The only difference, right? So let's talk about that. Let's say now we're going to talk about 0, right? So is 0 a natural number?
No.
No, but it is what else?
Whole number.
Why
It is-
it a natural number?
Just stay with me. It's whole and just a whole number is all 0 is?
Whole, integer.
And rational.
Integer and rational. I can't spell today. Okay, remember, the only difference, you guys, between whole numbers and natural numbers is the number 0. So, unless you're talking about 0, if it's a positive whole number, it's going to be natural and everything else. So 0 is the only one that does not fall in the natural number category. Okay? All right, last one I'm going to show you on this, and then we'll move on. What if I have negative 25 over 5?
Irrational. Oh, wait, no.
Rational.
So we know it's rational because it's a fraction. Could it be anything else?
Could be an integer.
How do you know that?
Because there's a negative and then a positive.
But it's a fraction.
Yeah.
But,
So can it be an integer? Tell us, Vincent.
yes, because if you put, because next, it
Yeah,
equals a whole number.
Yeah, what's negative 25 divided by 5?
5.
Negative 5.
Negative 5, right? So is negative 5 an integer? Yes. Okay, and we already said it was rational. So here's the thing you have to be careful on this, you guys. Just because it starts out like this does not mean that's the only thing you have to look at. You might have to simplify it before you answer your questions. Does everybody see that? Okay, let's talk about writing fractions. Okay, can anyone raise your hand and tell me, how would you change a mixed number into a fraction, Kylie?
You would, like,
Yes.
how many times 6 can go, like, how many times, like, okay.
You have the right idea, wrong execution.
6 times 6,
Okay, 6 times 6 is what?
36,
And then
plus 1.
plus 1. What's 36 plus 1?
37.
37. What would you put that over, Kylie?
6,
How do you know to put it over 6?
because that's the, like,
What's this called? Denominator. Good. So every single time, you guys, you have a mixed number, you start with the whole number, you multiply down, add up. Okay? All right, somebody else tell me, what about negative 23? How would you write negative 23 as a fraction? Raise your hand if you think you know. Come on, surely there's more than just 2 people in this room that can answer a question today. Ethan? All you have to do is put it over what?
Yep. 1.
Okay, you guys, anytime it's a whole number or an integer, right? A positive or a negative whole number, all you have to do to make it a fraction is put it over what? Okay? Reason, 4 2/3. How would you change it to a fraction?
4 times 3 is 12,
Okay?
plus 2 is 14 over 3
And you always put it back over
is on,
the denominator. Okay? Is everybody okay with those 3 examples? Any questions?
no.
Okay? Let's talk about changing a decimal to a fraction. Does anyone think they know how to change a decimal to a fraction?
Yes.
Okay. Anybody besides Kylie and Kaylee and Ethan?
My name is Julie. I changed it.
Bella, do you know?
It's Jamie.
Jamie.
PJ, do you know?
No. Come on. 6 times 4.
Dylan?
Come on.
All right, Kaylee, tell us.
0.64 over 100.
You're close.
So 64 64 over 100.
Okay, there we go. Okay, so how did you know that you should put 64 over 100?
Because it's on Alex.
Do what?
It's on Alex.
Okay, but we need, everybody in here needs to know why. Ethan?
That's why it's called 100.
Yes. What place value is the 4 in?
100.
The 4 is in the hundreds place, okay?
I just always thought if it was over 10, it was over, like,
Wait, so
if like 64, it's over 10, so now
You
the
just
bottom number's gonna be 100.
Sure. Well, here's the deal, you guys. Here's the reason a lot of people don't know how to write a decimal as a fraction, because what do we say that decimal is? We call it what?
Point.
0.64. Is that really how we should say it?
No.
No, we should say it's 64 hundredths, okay? So that will help you if you will just learn, okay, how to say an actual decimal. But also, all you have to do is look at what place value is your last digit in. It's in the 4's place, okay? And just like Kylie said, right, you've got, the only problem with that is, Kylie, I'll show you in just a second, with the way that you said it's over 10. Kylie, are you with me?
Yeah.
Listen, y'all need to put that up while I'm teaching, okay? Now, I'm going to tell you why on our next example, Kylie, why the way you said can be a problem sometimes. First, somebody tell me, is this 64 over 100 how I should leave my answer?
No.
What should I do to it? Simplify, okay? What can I divide both of those numbers by?
4.
4 does work. What's 64 divided by 4?
No idea.
Well, use your calculator then. You guys all should have calculators with us. Thank you.
28.
Okay, 16 over 25. Can 16 over 25 simplify any further?
No.
No. Okay. Now, here's what I'm going to show you, Kylie, on the way you said being over 10 and knowing to put it over 100. What if you have this 0.09?
And like,
Isn't 9 still less than 10?
yes, but it's like, still
It's in
got
the
a
ninth
zero.
place, so it's
But it's still in what place?
the ninth place. In the 100th place.
It's still in the hundreds place, so would I put 9 over 100?
Yes.
Yes. Okay.
I
Can-
always, if there's a number in the second,
Hold on. Yeah, say it again, Kylie.
like if there's,
Hey.
even if it's a 0, if there's 2 numbers after the decimal, it registers to me as 100.
Yeah. Now, something you could use is however many numbers are after the decimal, that's how many zeros you're going to use.
Yeah.
Okay, that would work also. All right. Let's look at this. What if I have 9.675?
Huh?
Dylan,
9.96 over 100.
do what?
Huh? What are we doing?
Okay, we're changing this to a fraction in simplest form. Okay,
Would you do
fraction or mixed number. Okay, go. Would I do what?
Would you do not 9675 over 1,000?
Like this?
No. Yes.
Is that what you're saying?
No.
What were you saying?
9675 over 1,000.
Okay, but why would I put 9,675 over 1,000 if 9 is in the ones place?
Oh.
So all the other ones, right, had 0. That's why we didn't put anything in front of our fraction. So is it not true, Charlie, that 9 is in the ones place, so I should keep that as a whole number?
Yeah.
Yes. Do I need to move you two so we're not talking the whole time? Okay. Still not a better answer. You should sit up and pay attention. Okay. If you have a number in front of your decimal, that will be a whole number every time. Okay, so you'll write that as a whole number. Everything after the decimal is what you need to write as a fraction. Okay, can anyone tell me how I could simplify this fraction now?
Yes.
Do 6,
What are both of those numbers divisible by?
5.
5, also
Also what? Oh,
25. Okay, all right, somebody do 675 divided by 25, please.
27.
Okay, and 1,000 divided by 25 should give you 40. Okay, so every single time, Ethan, that we're doing this, we're going to put whatever the place value is of that last digit, we put it over that place value, right? So if it's in the tens place, it's over 10. 100 would be hundreds, thousands, and so on. Ben, do you have a question?
Why do you divide it by 25?
Why, as opposed to what?
Like, how'd you get that number of 37?
How? Well, because when I look at a number, I think in terms of like quarters, right? So I think like $6.75, I could divide by 25 because that's like how you would count using quarters. Same thing with the bottom. If you thought of it, using quarters, it's already divisible by 25. Now, could you divide by 5 and then just divide again by 5? Yes, it's just going to give you another step. Okay? All right, questions on that part? All right, last thing I'm going to make really easy for you.
This is hard.
Okay, what part are you confused about, Dylan? But everything's not an answer. You need to give me like a specific part that you're on this part. Like writing a decimal as a fraction. Do you know place value? Like tenths, hundredths, thousandths? Okay, because that right there, if you know place value, you can write a correct fraction every single time. Okay? Tens place is always the first number after the decimal. Hundredths place comes after it. Okay? Hey, whoever keeps tapping their pen, please stop. Are you with me on that, Dylan? Tenths, hundredths, thousandths, every single time. Okay? All right, last thing we're going to do is change a repeating decimal into a fraction. Now, there is a long process to go about this. I'm skipping straight to the easy way, okay, and showing you kind of because that's just where we need to be, okay? So, this is similar to what we do with a regular decimal, okay? The only difference is instead of using 10, 100, 1,000, you'll use 9, 99, or 999, okay? So all you have to know is how many numbers are underneath the repeating sign here? 1. What is that number?
3.
So that goes on top, and you're going to put it over 1, 9, because there's only one number that repeats, okay? Let me get through a couple examples before you ask a question on this, okay?
Oh.
Just, hey, what did I just say?
So if there's
Hold on, just hold on. Let me get through a couple examples, and then you can ask your question, okay? Now, should I leave this as my answer? Yes or no? Why? Okay, both numbers are divisible by 3, so I would get 1 over 3, okay? Okay, here's the question you were about to ask, Dylan. Dylan, how many numbers are under your repeat sign? 2. What should you put on top of your fraction?
42.
42. How many 9s should you put that over? 90.
3.
99.
Yeah.
Just listen, because you guys, I can show you the long example of how we get to this, but that's going to confuse you more than just knowing this, okay? However many numbers repeat, that's how many 9s you're going to put it over.
They're not gonna have
Okay.
a single zero.
No, not on the bottom, okay? Now, can I simplify 42 over 99?
No, you can't.
Yes, I can. So both are divisible by 3, right? 42 divided by 3 would give you 14. 99 divided by 3 would give you 33. Okay, last one, I'm going to let you get started on your work. Okay, how many numbers repeat here? 2. Now, would I write 0, 3 on top of my fraction or just 3?
3.
Just 3. But how many 9s am I going to put that over? 2, because 2 numbers technically repeated. Okay? Then all you have to do is simplify. Both of those are divisible by 3, so you're going to get 1 over 33. Because I know that 3 is divisible by 3, and I check and see if 9 is divisible by 3, and it is. Okay?
Can I ask my question now?
Yes, while I'm writing this, you can.
Okay, on the 0.3 repeated,
Yes.
or I guess on all of them, why do you put 9 and not over 10 or 100?
Because if you put it over 10 or 100, it's not going to be a repeating decimal. It's just going to be a regular decimal. Okay? That's what I was talking to you, Kaylee. There is a long process you can use where you set it equal to a variable, you multiply both sides by 10, get rid of your variable. But if I show you that, that's going to confuse you more than just going straight to this method. Okay? So I'm kind of letting you guys use the easy method of putting it over 9. Now, here's what I would suggest to you. this is something I would put on my cheat sheet. I would put an example of how do I change a repeating decimal to a fraction by putting it over 9 or 99, whatever. And I would separate that from how you do a regular decimal, which goes over 10, 100, 1,000. Yes? Okay. All right. Make sure you write down for